omega by x of omega. Y of omega is Fourier transform of output, and x of omega is a Fourier transform of input. So it is defined as, the transfer function is defined as the ratio of output yt or Fourier transform of output. So ratio of Fourier transform of output to the Fourier transform of input. So this is the definition of transfer function. So let us see this. So first let us find out what is yt. Yt, already we have seen this. It's an integration from minus infinity to plus infinity. Xu h t minus u d. Now we have to find y omega. So we have to apply Fourier transform on yt. So y omega is equals to, the Fourier transform of yt is integration from minus infinity to plus infinity yt e power minus j omega t dt. So y omega is equals to integral from minus infinity to plus infinity. Let us substitute yt. It is given as integral from minus infinity to plus infinity xu h t minus u du, okay, times e power minus j omega t dt. So let us rearrange this as integral from minus infinity to plus infinity xu integral from minus infinity to plus infinity h t minus u e power minus j omega t, and just like adding j omega u minus j omega u, so that they gets cancelled and that leaves us e power minus j omega t only. Dt d. Let us write it again like this: integration from minus infinity to plus infinity xu integration from minus infinity to plus infinity h t minus u e power minus j omega t minus u dt, and let us write e power minus j omega u outside d. This is the transfer function h omega. So Fourier transform of ht, okay, h but h omega is equals to integral from minus infinity to plus infinity h t minus u e power minus j omega t minus u dt. So finally what we have, y omega is equals to integral from minus infinity to plus infinity xu h omega e power minus j omega u du. Integration is with respect to u. H omega is independent of u, so it is constant. We can move it outside the integration. Y omega is equals to h omega integral from minus infinity to plus infinity xu e power minus j omega u du. What is this? Can anyone tell me? This is x omega, right? So finally what we have? Y omega equals to h omega into x omega, or h omega is equals to y omega by x omega. So this way you have to prove the transfer function of a linear system. Okay. Next, let us find out the Poisson vector density of second parameter, Poisson vector density of yt. So s double y omega we have to find. So how to find it? Just we have to the relation. First let me write the relation. S double y omega is equals to magnitude square of h omega times s double x omega. This one we have to prove. Okay, let us prove it. The input and output Poisson vector density are related by s double y omega equals to mod h omega square into s double x omega. It's a very important proof. So s double y omega, you get the Poisson vector density by applying the Fourier transform on the correlation. Which correlation? Autocorrelation function. Already we have obtained if r double y tau in the last class. So let us apply the formula of Fourier transform, integral from minus infinity to plus infinity. So we are applying the Fourier transform on r double y tau, e power minus j omega tau and d tau. This is a function of tau. R double y tau already we have seen, we have derived in the last classes. So let us, I am writing directly. R double y tau is integral from minus infinity to plus infinity, integral from minus infinity to plus infinity, r double x tau plus u1 minus u2 hu1 hu2 du1 du2 e power minus j omega tau d tau. So s double y omega is equals to integral from minus infinity to plus infinity. I am writing hu1 here, and integral from minus infinity to plus infinity hu2 here, and integral from minus infinity to plus infinity r double x tau plus u1 minus u2 e power minus j omega tau d tau du1 du2. Okay, is equals to integration from minus infinity to plus infinity hu1, integration from minus infinity to plus infinity hu2, integration from minus infinity to plus infinity r double x tau plus u1 minus u2 e power minus j omega tau. I am going to add j omega u1 minus j omega u2 minus j omega u1 plus j omega u2 d tau du1 du2. The correlation function is a function of tau plus u1 minus u2. So exponent is should be also the same. That's why I have added j omega u1 and minus j omega u2 and subtracted. So let us write this way. Integration from minus infinity to plus infinity hu1 e power minus j omega u1 du1. I am splitting. Integration from minus infinity to plus infinity h u2 e power j omega u2. Integration from minus infinity to plus infinity r double x tau plus u1 minus u2 e power minus j omega tau tau plus u1 minus u2. So this is plus and this is minus. This is the second one is du2. This is d tau. So this integration is h star omega, and the second integration is Fourier transform only. This is h omega Fourier transform of hu2, and this one is it's a integration of Fourier transform on correlation function gives you the power spectral density is double x omega. So finally h double y omega is equals to h star omega h omega s double x omega. X star into x is mod x square. So s double y omega is equals to mod h omega square s double x omega. So this is the relationship between the power spectral densities of output and input. This is very important derivation. And the third one, the cross power spectral density is the sxy omega is equals to h omega into s double x omega. So let us prove it. See what we have to do. First we have to apply the formula of sxy omega. So omega means frequency domain. So we have to apply Fourier transform on cross correlation or xy tau. Okay. This is integration from minus infinity to plus infinity r x y tau e power minus j omega tau d tau. This is sxy omega. Already we have seen, we have already derived rxy tau. You go back to the previous class and check what we have obtained. It is integration from minus infinity to plus infinity r double x tau minus u hu du. So let us substitute this. Sxy omega is equals to integral from minus infinity to plus infinity, integral from minus infinity to plus infinity r double x tau minus u hu du e power minus j omega tau d tau. Let us rewrite this as integration from minus infinity to plus infinity hu e power minus j omega tau. I am writing here. Integration from minus infinity to plus infinity r double x tau minus u e power minus j omega tau e power minus sorry, let me write this as u du, so plus u. tau minus u du. Okay, in the first integration I have included e power minus j omega e. In the second integration I have included e power plus j omega u. Both gets cancelled and that gives the same expression. This first one equation is h omega. Second equation is what? It is the Fourier transform on autocorrelation function. The Fourier transform of autocorrelation gives the force vector density. So cross force vector density is equals to h omega times s double x omega. Very simple proof. And syx omega, it's also cross force vector density, but this time I have changed the order xy to yx. This time you get h minus omega s double x omega. So this is homework to you. It is same as the last proof, the above proof only. Okay, so let me give you some concepts. Low pass signal. Low pass signal means the distribution of power is at origin. Y axis is s omega, x axis is omega. The power is at origin only. Power is centered at omega equal to 0. Whenever a signal is having its power at omega equal to 0, those signal is called low pass signal. And a band pass signal. The band pass signal has a lower cutoff frequency and upper cutoff frequency, and its power is not at origin. It is not at origin. It is somewhere like this. Okay. Let me say this is plus omega naught, and this is minus omega naught. Okay. So in this, power is centered at omega equals to plus or minus omega naught. Those kind of signals are called band pass signals. Okay, now one more concept. This is a band pass filter, and for this I am applying the noise which is a wideband noise. Wideband noise. So wideband noise means the range of the frequencies are the range of the frequency is very high. The range of the frequency is more. And what is a band pass filter? Can you tell me? So normal definition, you know it. Let me write the output is N naught T. Even though the bandwidth is very high of the input, the band pass filter allows only certain range of the frequencies. Okay, so after the band pass filter, the signal is called band pass or band limited signal. The output of band pass filter is called band pass or band limited signal. Okay. Next, I'm going to give you did I give you the Fourier transform pairs? Can you answer me?
Yes, sir.
And did we solve the problem on it? RWX tau equals to 1 by 2 e power minus a mod tau. Please answer me now. Otherwise,
Yes,
okay.
yes, sir.
Yeah. Now we are going to solve one problem on the basic circuit. Find the output power spectral density of the following circuit. Assume white noise process is applied to the input. Okay. This one problem is equals to many problems. I'm drawing this circuit. Tell me what is the name of this circuit. This is input xt. This is output yt. Can anyone tell me what is this circuit name?
High pass.
High pass. So what we have to find is in this circuit output power spectral density. What is the relationship between input output power spectral densities? S double y omega equals to magnitude square of h omega square, magnitude square of h omega s double x omega. What is the input given? What is the input given? Can anyone answer?
White noise.
Yes. Next is white noise process. White noise process. Can anyone tell me what is the power spectral density of white noise? N naught by 2. It is N naught only. To take it like that only. Now you have to find h omega transfer function. How to find transfer function when these kinds of circuits are given? You have to apply voltage division rule. You have to apply voltage division rule. So first let me give you about the voltage division rule. After that we can go out. Let me say this is VIT. ఈ VIT నే మనం XT అంటున్నాం. This is V0T. V0T ని మనం YT అంటున్నాం. R1, R2. Can someone tell me what is V0T? Voltage division rule. It is R2 by R1 plus R2 times VIT. Okay. Am I right?
Yes, sir.
But this is in a time domain. Only R1, R2 are there. but in the given example capacitor is there. Okay, so I'm going to write you, let me write this is in time domain. In time domain R itself R only. Okay, itself is R only. Does it depends on frequency? Okay, resistor depends on frequency. Anyone? Inductor, it is equivalent to J omega L, and capacitor, it's equivalent to 1 by J omega C. Okay, now let's go back to our circuit. Capacitor, resistor. Now we are writing this in, we are drawing or writing this circuit in frequency domain. Now, how we have to write the capacitor as 1 by J omega C. Resistor itself R only. Now, apply voltage division rule. Voltage division rule. Now, can you tell me what is output? Y omega equals to R by R plus 1 by J omega C times input. What we want? Y omega by X omega, which is nothing but H omega. So we can write it as J omega RC by 1 plus J omega RC. Y omega X omega is H omega. So this is J omega RC by 1 plus J omega RC. We can write this in other way. How can we write this as F by F1 1 plus J is there, F by F1, where F1 equals to 1 by 2 pi RC. Anyway, we have H omega. What we want? Mod H omega square we want. So mod H omega square is we have to apply magnitude on this. Magnitude of J omega RC by 1 plus J omega RC. So what is the magnitude of X plus JY? Mod of X, it's a root of X square plus Y square. So mod H omega square is equals to omega square R square C square by root of 1 plus omega square R square C square. So finally we have to substitute in the output power factor density formula. S double by omega equals to omega square R square C square by root of 1 plus omega square R square C square times input power factor density is N naught by 2. This way you have to find out. I am telling you it again. Whenever a circuit is given, in case capacitor is there, if there is an inductor, you have to replace the inductor with J omega. Just write J omega L at the place of inductor. Okay, write input as X omega, write output as Y omega. Okay, apply voltage division rule. Apply voltage division rule. So from that we get Y omega by X omega, which is nothing but H omega. Apply mod on that and square it. substitute in the output power crystal density. Any doubt in this? So for practice, I'm giving you more problems. Okay, this is R, this is C. So in frequency domain, how you write R itself R? In place of C, what you have to write? Anyone? In place of C, what you have to write?
1 by j omega c.
1 by j omega. And in place of L, what you have to write?
J omega L.
Very good, very good. కొంచెం కాంప్లికేట్గా ఇచ్చాను అనుకో ఒకటి ఇలా ఇస్తాను. Even though you have to apply the voltage division only. Are you getting? Can you tell me what is the impedance in this parallel path? R plus 1 by j omega c. That is the impedance in this RC path. R and C, this R and C are in series. So you have to add the impedances. R plus 1 by j omega c. Now you apply voltage division rule. R plus 1 by j omega c by 1 by j omega c plus R plus 1 by j omega c. That's it. Okay, let me give you one more problem. After that, L and this is C. So try these problems. Input is white noise, that is perfect densities are not by P. Okay. The last topic in this subject, introduction to Markov process. Introduction to Markov process. So let us get some random variables. So for that I am going to plot xt versus t, where this is a random process. I would like to get some random variables xt1, this is t2, xt2, and tn, so xtn, and the next random variable is tn plus 1, xtn plus 1. Can anyone tell me what is a present state and next state? What is present state and next state?
With present inputs.
Yes. Here xt1 is a random variable only. I am taking this as a present state. At present, this is the random variable. Okay, it's a present state. Xtn plus 1, it is a future state or next state. Definitely it's a future state here. Future state or next state. The Markov process discusses about future state. Does it depends on present state or previous states also? I think మీకు STLE లో sequential circuits and combination circuits and discuss చేసి ఉంటారు కదా. What is a combinational circuit and what is a sequential circuit?
ప్రజెంట్ స్టేట్స్ అయితే కాంబినేషన్ సైకిల్స్, పాస్ట్ అయితే పాస్ట్ ఇన్పుట్స్ తో సీక్వెన్షియల్.
Very good, very good. Here also, the future state depends on present state only, not on the past states. That kind of the processes are called Markov processes. Very good. So Markov process or property states that the future state or probability of process depends on present state. It depends on present state only. And not on the past states. And not on the past states. So I'm going to write this mathematically. Xtn plus 1 given xtn plus 1 equals to small xtn plus 1. Okay, given xtn is equals to xtn. Is it correct? I'm writing conditional one. The first event is always written after the slash, and the next event is written on the left side of the slash. This is for continuous random variable. And the second one, xn plus 1. Let me write j, and xn is equals to I. This is also same thing, but this is for discrete random variables. I have written the statement as a conditional event and probability of conditional event. Okay, with this, the subject is over. Tomorrow we will see the binomial theorem derivation that is left in the first unit. Assignment 2.
Mid 3, 4, 5 chapters, sir.
Yeah, 3, 4, 5. Maybe it's for 3, 4, 5.
Okay, sir.
Okay. So I will post the assignment 2 in the Google Classroom. Anyway, the questions are: write the properties of joint distribution and joint density functions. That's the first question. Second question is: write the properties of autocorrelation function, cross correlation function, and covariance function. And the third one: write the properties of auto post vector density and cross post vector density. So these are the what we call assignment 2 questions. Any doubts in this today's topic? ప్రిపేర్ వెల్ ఫర్ ద సెకండ్ ఇంటర్నల్ డేట్స్ వచ్చిండే కదా. పీడిఎస్ ఎప్పుడు ఉంది?
4th Feb.
4th Feb. ఓకే, బాగా రాయండి. ఫస్ట్ ఇంటర్నల్లో బాగానే వచ్చాయి కానీ ఓకే, ప్రిపేర్ వెల్ అండ్ రైట్. Any doubts? If no doubts, you can attendance here. Sir, are you there?